Hello, everyone. My name's Alex, and I'm here to talk to you today about why I think everyone can be a full-stack software engineer. Currently, web apps are built often with large teams of engineers, with each engineer just owning a little piece of the puzzle. But I think that there's a better model for developing modern web apps, one in which individual engineers get to own their feature all the way from the top of the stack to the bottom. I think when you do it this way, you can ship more product features faster, and individual engineers are able to think deeper about the product experience. So when I say modern web app, what am I talking about? I'm talking about apps like these, apps like Facebook, Airbnb, Slack, Asana, Reddit. What do all of these have in common? First, they're websites that have dynamic content. We're no longer serving static HTML to everyone on the internet. Instead, different information is served to each user that's pulled from some kind of database. So the app is personal and has user-generated content. The second thing is that these apps, at least when they're done well, are reactive. When a user loads the app, they'll see the changes to the data happening in real time. You don't have to refresh the page, but the most up-to-date content is pushed directly to the browser. And the last thing is that these apps are all interactive. Not only can you view data, but you can add your own content, write posts, write messages. And when you do that, you see your own edits update in real time. And so the sum total of all of these properties together can make these apps, when they're done really well, just feel native. Users are no longer feel like they're on a website, but they feel like they're having a rich native experience. And this is what I want to talk about today. I want to talk about how you build apps like these, and how we can design the infrastructure for these apps to enable individual software engineers to own the whole stack. But before we do that, who am I? Hi, my name's Alex. I'm a software engineer at Convex. Convex is a reactive backend as a service. We're helping people build their web apps on top of our serverless infrastructure, so you don't have to manage all the infrastructure yourself. So we've been doing a lot of thinking about what are the right ways to build web apps today. Before this, I worked at Asana. I was leading the client infrastructure team. This was a team that was building out the reactive web framework that Asana uses internally. So I also did a lot of thinking there about what are the right abstractions to give product engineers, and how can we put product engineers into the pit of success. So all of this combined means I care deeply about how we build modern reactive web apps, and I want to tell you a bunch about my thinking today. So first up, I want to talk about the architecture that most apps are using today. What is happening behind the scenes in these large web apps, and what kind of problems do these architectures hit? So let's start by talking through a example web app. What do we need if we want to get our app off the ground and serve to users? Well, we're going to need a couple things. We're going to need to build a front end. Probably we'll build it in React. We'll write some React components and put together the UI that we really want to deliver to our users. That front end is going to need to go and talk to some kind of backend. We're going to need a way to run server-side business logic. And probably we're going to define some endpoints or GraphQL schema and GraphQL resolvers to load and mutate data. The dotted line in this diagram represents the boundary between the client and the server. So the front end is going to make some requests to the back end. And then on top of that, we need some way to permanently store data. So we're going to need some type of database, perhaps MySQL or MongoDB. And that's going to store data based on some schema for our app. And to start, this is it. Many apps will, sort of launch with a 3-level architecture like this and get right off the ground running. But once our app is wildly successful, we're going to hit some limitations here. And I think one of the first limitations we're going to hit is that an individual backend might not be powerful enough to serve all of our users. We could have problems like the backend is going down because there's just too many requests. Or every time we rewrite the code in the backend, we have to swap it out for a new one, and there's downtime. So likely the first step as we're growing our application is that we're going to need to expand the backend to no longer be a single service, but instead we'll run multiple copies of the backend and have a load balancer in front of them. This will give us some redundancy. So if one backend goes down, we'll be able to handle that fine. And it will also help us because now when we redeploy code, we can have our load balancer talk to the new backends instead of the old ones and sort of do seamless transitions. And yeah, Asana started out with an architecture very much like this. Cool. So are we done? Are we ready to check off and just, run our app and keep it in production like this? I think not. I think as our user base grows, we're not at the end of our scaling woes. And I think the next part of our system diagram that may have issues is the database. Here we're running a single database, which once again means that it can be a single point of failure. If our user base grows enough, we're no longer going to be able to handle our traffic in one database. And if we don't have a database, we don't have an app. So I think the next step in our scaling is that we're going to want to shard the database. Instead of running one big database, we're going to probably want to split our customers' content into separate shards where different shards live on different databases. This will let us horizontally scale the database layer and grow to more numbers of users. And it also means that an outage on one database won't affect everybody. Also surprisingly, Asana started out with a single database and reached those limits. And as anyone who's done sharding knows, it's no easy task, right? When you're doing sharding, you're going to have to break up your work into that maybe crossed multiple different parts of your data model into work of individual transactions on databases. So you're going to need to only be able to do a transaction on one database. And if you want to write data to multiple databases, you're going to have to think through the consistency of it yourself. But that's fine. We're a big web app. We have a big team. We're going to have some people who have thought hard and long about MySQL and the right way to shard, and they're going to split up our data into multiple databases. What's next? Are our scaling woes and our performance problems over? Once again, I think it just keeps getting more complicated. So next up, I think we're going to need a way to improve performance beyond the database. Like for many apps, loading all of your data from a single database or a set of databases is fine, but it's also increasingly popular to have a caching tier as well. So here we'll have some kind of cache nodes that are storing in memory a lot of the data from the database. These might be services like MySQL or Redis. And instead of the backend loading data straight from the database, at least for some kinds of content, it can go to the cache first, see if the data is in the cache, and then follow up and go to the database. And if any of you have experience with caching, you will know that I just brushed under the rug a tremendous amount of complexity. As soon as you add a caching tier, now we're going to have to make sure that the data in the cache actually matches the data in the database. It is extremely easy to end up with cache inconsistencies where some user, edits data in the cache but fails to write to the database, or vice versa, where they write to the database but don't update the cache. And these might seem like small problems, right? Like, okay, the correct data is still saved in the DB. What's the issue? But when the users are showing up on your site, what they're going to see is the information in the cache. And so if it differs from the database, they're going to believe that their content was lost or corrupted. So likely building out this infrastructure, we're now going to need more engineers with more expertise to make sure that the caching layer and the database stay in sync. Okay, fine, we did that. We've built the cache. Alex, are we done? Are we ready to launch our web app and scale up to the entire user base? It keeps getting worse. So I think the next problem we may run into is actually a product one of, I said we were building these really interesting reactive interactive apps, but the architecture diagram I've drawn here is really only about loading data and writing it. How are users going to see content when it changes? So we're going to need to make it reactive. So the standard way to make it reactive would be to change our front end to no longer use HTTP to request its data, but instead have some long-lived WebSocket connection to the backend. That's the double-ended arrow. Using a WebSocket means that we can still load data on the front end by requesting it from our backend, but also it'll keep a connection to the backend open, so the backend can push data all the way to the front end. But I guess how is the backend going to know when to push what data? This will require yet another new piece of infrastructure. A common choice is to use a pub sub service. And the idea behind this is that the backends will be able to like publish topics to the pub sub service whenever they edit any information, and they'll subscribe to the information that their clients currently care about. And the pub sub service will sort of act as a message broker, letting the backends know when information changes. And yeah, Asana also did exactly this. Asana had an in-house pub sub system they built themselves and broke up the data model into these fine-grained pub sub topics and used those to like push around information so that anytime you're viewing content in the app, you would see it change in real time. But once again, there's a lot of complexity here. There's a lot of complexity in getting the correctness right of how do you correctly publish and write to the database at the same time? You can't. There's complexity in making the front end be able to like understand the messages about changes to information, right? We're going to need some way for the front end to have some local client store and store all of this data and update it as it changes. But okay, we've already scaled up our team. We're going to have some set of people that are working just on reactivity and pub sub. And yeah, about now is when I run out of space in the screen, but that doesn't mean that the complexity stops growing. I think in many modern web apps, there's actually a lot more boxes in this diagram. Some other common choices are that if your product someday needs to have full text search, you want the ability for users to search for messages by the text in them, your existing database might not be able to handle that. So you add in a whole nother database. We can start running something like Elasticsearch to fill those queries. So at some point, we might want to be able to do things like send emails in the background. If we want to have background jobs, we're going to need some sort of job queue where we can schedule jobs to happen and workers that actually do the work. We're probably, as the site scales up, going to need to have analytics. People are going to want to know what users are doing on the site, how many users we have. So we'll also need to add in a data warehouse. And it just keeps going. And I think, yeah, basically, as I've described here, this is the state of the art for modern web development. You're sort of combining together a bunch of different services, and it's your responsibility to wire them all up in the right way and keep them consistent. And it works, I think almost every logo I have written on the first slide was built in this kind of way. But there's also some downsides. And I think one of the big questions comes down to the people involved. How many people are we going to need? How are they going to be divided up into teams? And so for this sort of imaginary app, we're probably going to need a front-end team. We're going to need some people who know how to write really good JavaScript and TypeScript, CSS and HTML, because we're building a site for the web. And there's a bunch of specific technologies that this team is going to have to be experts in. They're going to need to be understanding React, GraphQL. They're going to need to know how browsers work and, be thinking through the UI. On top of this, we're probably going to need a separate backend team. These are people that are going to be writing our backend business logic. And probably we picked a backend language like Java, Python, or Ruby. We're going to need to be doing SQL queries from the backend in order to load our data. And these engineers are going to have to think really hard about performance and security. Right. So we have a front-end team, a team that writes the sort of back-end business logic. But what about all the other boxes in this diagram? We're also going to need to have another team, some sort of SRE, DBA, or infrastructure team. This team would think a lot about scalability, reliability, correctness, and performance, and probably be doing a lot of writing configuration, scripts, SQL, to keep sort of the site running and everything correct and performant. Okay, this is a lot. I had a diagram that filled the whole slides of the architecture. We have 3 different teams here, and we know we need all of that before I've even told you what kind of app we're actually building. Pretty wild. But just to round this out, let's think about what product development looks like in this kind of model. So yeah, let's imagine now that we actually want to go and add a new feature to our app, given this architecture and these teams. And sort of as a toy feature to talk about adding, let's imagine that we're building a chat app, kind of like Slack, and we want to add channels to the app for the first time. So we already have a single channel chat app, but now we want to go and add the ability for users to, have custom channels, send messages in those channels, see the full list of channels, all that good stuff. So what do we need to do to add channels? All right, well, first, we're going to need to think at the bottom of the stack. At the database layer, we need some way to define a SQL schema and define what our data model is. This is probably going to be a conversation between the backend team, who is thinking about what kind of endpoints we need to write, and the infrastructure team, who is thinking about scalability and performance. And so they're going to agree on a SQL schema. Once they do that, we're going to need to actually go update our database to have this schema. So maybe the infrastructure team is going to go add the schema, whatever appropriate indices we think we'll need, and also generally scale up the services to support this new feature. Okay, great. We have the schema. What's next? Next up, we're going to need the backend and front-end teams to talk to each other to define the API of the endpoints. Right? If we're building a chat app, we probably need a way to load the list of channels. We're going to need the way to load messages that are in a specific channel. We're going to need to be able to create channels, delete channels, rename channels. And we're going to need to make sure that the front-end team is getting all of their needs met by the endpoints, but also that they can be implemented by the backend team. And often I've seen teams that will jump to GraphQL to solve this. Because this conversation is so difficult, it's often nice to have a rigid structured language in order to sort of guide the conversation and write down the conclusions. Okay, backend and front-end teams. We've defined the API. Finally, the backend team can go and actually build the endpoints. They'll implement this API and use the SQL schema that the infrastructure team set up for them. And finally, only then can we actually go and build the components and actually build the UI. And so now the front-end team can write the components, and we have built our new feature end-to-end. So how do we feel about this process? So in total, we had over 6 different services involved. There were 5 steps. We had at least 3 teams. And so I think realistically, even for a small feature like this, it's going to take weeks. There's just too many moving parts involved, too many different people. And sort of the work of developing the feature has been split up between totally different teams, so that no team is thinking about this feature end to end. Everybody is sort of focusing on their part and throwing a bit of work over the wall. Okay, can we do better? What does a better model look like? What does a world look like in which people could actually own their features end to end? I guess to sort of say the negative version here, in this existing model, how could anyone be a full stack engineer? It seems completely infeasible for a single engineer to be thinking about or owning this much infrastructure. And so, if you stop the talk now, I will have convinced you of exactly the opposite of my goal. It seems impossible. Okay, but how could we do it? What would it look like? And so I think the thing I want to talk about next is what a serverless architecture would look like for building a complex web app like this. How does serverless change things, and how does it change the teams that are building the apps? And so I think before we talk about what architecture we're actually going to use, I think we should come back to this complicated one that we had before and focus in on a question of what part is the app? Right? As I said before, I drew all of these boxes before I even told you what app we're building. What parts of these boxes actually have to do with the product features we're building? And so I think there's a couple of bits here. On the front end side, we're going to have different React components depending on what app we're building. Right? The React components are specific to the user experience we want to give. Similarly, on the back end, there's bits of business logic. Right? We talked about the fact that every new product feature is going to need new endpoints or adjustments to the endpoints. And when you sort of condense down what is an endpoint, all it really is a function, right? We need a function that's going to be taking in some like an HTTP request and returning some data to the front end. So there's some functions on the back end. And then the last piece that changes and is sort of part of our app is the database schema, right? Every app needs to store information in the database, but the schema they use to store it depends on your data model in particular. And so I claim that this is really it. Like when I think about what is the app, there's the React components, there's functions in the backend, and there's a database schema. Everything else in this diagram, that's just scaffolding to get these three things in place. And so if we want to sort of remove as much unnecessary complexity as possible, where do we end up? If we want to like empower engineers to edit the whole app, how do we do it? Well, I think we need to do a few things. We need to remove all this excess complexity, right? We want to focus in on just those three things, your React components, your functions, and your schema, and manage everything else by sort of centrally. The second thing is that if we want engineers to actually be able to edit the whole app themselves, we need to write all of these pieces in the same language. And given the realities of web development today, I think we have to pick JavaScript or TypeScript because that's the one that can run in the browser. Cool. And then once we've done this, profit. If we can remove all the complexity and write everything in the same language, I think we're going to be in a really good place. But let me convince you of this. So in the serverless architecture, these are the only things we need. We need React components, some way to build the UI. We need backend serverless functions, some way to have backend business logic and run code on the server. And we need a schema. We need to describe how we want to save our data in a database. And unlike the previous diagrams, like this is it. I'm not going to be pulling out any more complexity here because there isn't any more. I think these three ingredients really give us everything we need to build the app. And so when we've done this, let's break down what the responsibilities are. So if you're using a serverless architecture like this, right, you have to manage just those three things. You'll have to write UI components. You'll have to write serverless functions, and you'll have to define a schema. But where did all of the other parts go? How are those getting taken care of? Like if you're using a serverless provider, you're sort of giving them the responsibility for handling the scalability, correctness, caching and performance, reactivity, backups, availability, hosting, the whole list. And so I think we didn't do anything totally revolutionary here, right? I just took the responsibilities that used to be spread across a large engineering team and offloaded them into a like serverless hosting provider. And having personally worked on a large engineering team building Asana, I can tell you that a large fraction of the engineers were actually focused on all of these problems and not the UI components, the functions, and the schema. And so by sort of giving the provider all of these responsibilities, it will let you focus in on building the parts of the app that actually affect your user experience. Okay, cool. This sounds good in theory, but what does product development actually look like in this kind of serverless environment? So what I want to do is walk through the same example we did before, and I want to just show you how that would work if you're using Convex. I think a lot of the same ideas apply to many other serverless providers, but this is the one that I know well. So when you're using Convex, you write your schema in TypeScript. And so before you added messages to your chat app, your schema might look like this. So here, this is a TypeScript file. We're importing some helpers, define schema, define table, and S. And we're defining a schema that just has a single table messages. Messages are just objects that have two properties on them, author and body, and both of them are string, right? A very minimal chat app where people can post messages and say who posted them. If we now want to expand this into a chat app that has channels, right, we're just going to go ahead and add channels to our schema. So here I've updated the schema. Now there's another table called channels, and each channel is just an object that has a string name. And then we need to connect the messages to the channels somehow. And so in Convex, the way you can do that is by referencing the ID of the objects in the other table. So here, now messages have a channel property, and that's just the ID of a channel. And this is sort of how we handle foreign key references. Okay, define the schema. Took 30 seconds. What's next? Well, we need to define the backend functions. Once again, in Convex, this is all just written in TypeScript. And so this is an example of what the kinds of functions you might need to build this like multi-channel chat app. So the first function would live in a file like listchannels.js or ts. And it's using query here, which is saying that this is a convex query function. In Convex, query functions let you load data, and they're automatically reactive. So whenever you load a query function, Convex will also push to you a new version of the data whenever the underlying data changes. In this case, what do we want to do? We want to go to the database, we'll query the channels table, and just collect all the channels that we find. And that way we can list all of the channels in our little Slack channels picker. I should say, though, that in a convex query function, you can write arbitrary TypeScript, and it will still be reactive. So if we wanted to take the length of this list and list how many channels there are, we could get a live updating number of the number of channels in the app. Okay, and we don't just want to list the channels. We also need a way to add new channels. And we can define that using this convex mutation in an add channel file. So here, this is a mutation that takes in the name string and then inserts a new document into the channels table with that name. Nothing revolutionary here. But I think the cool part is that the same engineer who went and wrote the schema could easily hop over here and start writing the functions. Right? They're just sort of in the same code base, TypeScript code, nothing magical, nothing special. And then the last piece is that we actually need to use these functions to build components and add on that new UI for our new user experience. And so in this example, we'll probably want to make a new React component called channels list. And what does that do? Well, we need to load the channels if we want to list them. And Convex gives you a use query hook. Use query takes in the name of a query function and just gives you a reactive version of the result. So this is sort of a live updating set of channels. And then based on those, we're going to render some UI. So maybe we map through all the channels, and for each channel, we render a link that lets you load the messages in that channel. Cool. And that's it. You can load data from queries on the front end. You can call mutations. And that gives you all of the tools you need to build any interactive experience. Right. And I think when we've done this, it's almost, it is both completely obvious and also somewhat revolutionary. We've taken a process that was going to take weeks for 3 different teams to complete, and I just described how to do it in 10 minutes. And by using the same language and the same abstractions at every layer of the stack, it's now realistic for individual engineers to understand all of this and own their feature end to end. So instead of having people split up on what part of the stack they're working on, you can now have teams that are just focused on their parts of the data model and their features, and can think through how to build those features end to end. On top of that, I think there's some things that you get with serverless that are actually just hard to build in traditional architectures. And let me give you sort of my 2 examples of what you get for free by using serverless that may have never been able to be built using a traditional model. The first one is reactivity by default. When I say that, what do I mean? Often in an app, you're starting sort of in the way that I did in my example, where you start by calling endpoints and loading non-reactive data, and then adding on a pub subsystem, which will give you some amount of reactivity, but perhaps only to the things that you actually manually built it for. So it's very common to have apps where the chat portion of the app is reactive, but the other views are not, because that would be extra infrastructure and extra engineering complexity. In Convex, though, you actually get this for free. So anytime that you load a query on the front end, Convex pushes you updates to that query whenever the data changes. And so an example of the kind of experience I mean is look at these two windows. There's one here that's creating a channel, and then one that is like viewing the channels list. In Slack, for example, when you go and hit new channel and click the create button, the new channel pops up in the channels list immediately. And I think this is like sort of the detail that can take an enormous amount of work in a traditional architecture. But if you're using a centralized system like Convex that understands the data that query functions load, then it can push newer updates to those query functions whenever the underlying data changes. Pretty cool. The second sort of freebie that you get in this sort of system is end-to-end type safety. So because we've written all of our code in TypeScript on every layer of the stack, we can give you really good, precise generated types. So what do I mean by this? So here I'm like inside of a React component channels list, and I'm calling the use query hook in Convex. Use query now is like understands what query functions we've defined and auto-completes them automatically. So here you can see that there's a list channels query function and a list messages query function in our code base. Often this kind of thing can be built in other frameworks, but requires complex code generation to take your SQL schema and turn it into TypeScript, or take your GraphQL schema and build your sort of types for your GraphQL client. But in Convex, this is all piped together in end-to-end correct automatically. Similarly, the types can actually just flow all the way from the database layer up into your UI. So our like list channels query function was loading a list of like channel objects. And here, when we load those channels on the front end, you can see that it's just an array of documents that each have an ID, a creation time, and a name. So one field that we defined, two system fields that got added, but we can see them all in our editor right here. And I think this also helps engineers move faster across all layers of the stack, because they know that the types are going to sort of guide them through the process. Okay, thank you all for bearing with me. A couple conclusions and parting thoughts to walk away with. The first one is that most of the complexity in modern web apps has nothing to do with the app at all. Our sort of standard infrastructure and pieces that we wire together actually are amazingly complex. And that's part of what necessitates these large engineering teams where each individual engineer only owns a tiny part of the stack. Second, if we can remove this complexity, first, it obviously saves time. If there's things that your team doesn't need to manage, you can focus more on the other options. And it also changes how you actually work. When you're only focusing in on the parts of the app that have to do with your app, you can think about them more holistically and own the same thing, own features end to end. And the last thing, everyone can be a full stack engineer. Once you remove all the unnecessary complexity, it is completely feasible for engineers to work all the way from the schema layer up to the UI and think about an entire product feature. Thank you all for listening. If you have questions or thoughts, feel free to shoot me an email. My email is alex@convex.dev. And if you're curious about Convex, check out our website, convex.dev. We're hiring. Thanks, everybody.
Well done, sir. Really enjoyed that talk. Thank you so much for taking the time to educate the community on the basics of serverless. And we wanted to jump into this Q&A. So everyone in the chat, if you do have a question, just pop it in the chat and I will review those and pull the best ones and relay them to Alex here. But I wanted to start off with just a few questions. You talked about outsourcing our infra to teams who specialize in areas, we would normally manage in-house. Now, while this sounds great in theory to me, is there actually a complexity trade-off here when we outsource these critical tasks?
I mean, I definitely think about it as just moving around the complexity, not necessarily trading it off. of there is some inherent complexity in building the infrastructure for a modern web app. It's just a question if you're the in-house team doing it or an external team.
Mm-hmm.
But I also think it's interesting to put this in sort of the larger arc of like, how has like engineering big web apps changed over time? It used to be that you would have a server sitting in your garage that you would manage yourself and buy. Now with like hosted platforms like AWS, people switched to using EC2.
Mm-hmm.
In addition, people are increasingly using more managed databases like RDS. And so I think sort of the line about like which parts of the infrastructure you manage and which ones you're paying to manage is just continually moving up. And so sooner or later, people are also not going to want to be provisioning their own backends and that type of thing.
So perhaps it's not exactly more complex, it's just a different type of complexity.
Yeah, for sure. And the complexity is now moving into the realm of specialists who are building this as their business.
Mm-hmm. And I think many people who have really not tried this architecture may have a perception that it's not ready for, large scale production applications. What is your response to this? And just a quick follow up to that, are there any companies you know who are using serverless architecture at scale?
Yeah, for sure. I mean, I think as with any new technology, a lot of the early adopters are smaller companies who are more willing to try it out and take a risk. But I think sort of anecdotally, I'm definitely hearing about big companies that are dipping their toe in, testing the waters, using it for small features or small parts of their
Mm,
app. And some companies that are also just building their apps on top of it. Like certainly AWS Lambda, I think probably the biggest serverless product out there right now, has a ridiculously long, impressive list of logos on their website.
mhm.
Yeah, seems like Zillow, Coinbase, lots of people are switching and using Lambdas to simplify their stack. And I think certainly the trend is undeniable that, yeah, more companies are using this in the future.
So is that something you would recommend to get started with serverless? Is just try it out in some small section of an app or some small new feature
Yeah,
that's
I think sure. Like any new technology, you don't want
right.
to like move your entire, web app onto this and assume that it will work and be fine. But I think finding
Mm,
small ways to test it out, make sure that it works for you and your technology, I think is always a good way to get started.
great. I'm gonna pull some questions from the audience now. Jehan or Jehan Z, thanks you for your insightful presentation and asks how you manage migrations of schema.
So obviously, this kind of thing varies depending on which product you're using. Um, in the case of Convex, um, the schemas are actually pretty interesting because they're not, you can use Convex either with a schema where you explicitly write out what tables you have and what types those tables have, and then they generate TypeScript types, or even without a schema where you just put in data and pull it out and sort of keep track of this on your own. I think Convex currently has sort of limited ad hoc schema migration capabilities. You
Mhm.
definitely can go and write mutations that read out your data in one format and write it back in another. But we also are planning to add more automated schema migrations where you can write a transform from your documents from one format to another and have that run automatically. But yeah.
All right. And I'm gonna butcher this name, so apologies in advance. Vijaya Karthika G asks, how did QA adopt this transformation to serverless architecture?
Sorry, what's QA?
I would guess quality assurance. I'll ask
Right.
VJ to clarify that in the chat. We'll move on to the next question from Giuseppe B. How do you imagine these principles to work for teams having multiple front ends, web and mobile, or even only mobile?
I mean, I think the dream is that a lot of this just applies directly. And certainly, if you have an app that is only mobile, I still think it's a really good model to have the same engineers building out the app as the people building out the backend, because they can sort of think holistically about their feature. Um, and I'm also excited and interested in ways to break down the barriers between web and mobile at companies that have both.
Mm.
When I worked at Asana, there was actually a very hard line between the web engineers and the mobile engineers. And so product features that required launching on both were sort of this like complicated coordination game. But I think with new frameworks like React Native, where you can build your mobile app in React components, just like your web app, some of these boundaries are becoming a little looser. And I'm excited about ways in which the same engineers can build product on all the platforms.
Yeah, absolutely. This is what got me into the React community. I didn't really properly introduce myself. For those who don't know, I produced the conference Reactathon. So I've been very close to the React community for a long time. And it was really the keynote in, I think it was like 2014 to 2015 when they introduced React Native that I was like, oh my God, this is game changing. And it's proven to be. And now we have technologies like Expo. If for those of you who are interested in cross-platform development, I would highly encourage you to check that out. Expo is a technology where you can build for mobile across platforms and web with the same code. It's just incredible. Okay, let's go to the next question from Lely L. Can you host convex on Azure serverless infra such as app service?
I guess the short answer is no, not yet. Convex internally is running on top of AWS, but we actually manage all of that for you. So that's a implementation detail that we don't actually talk about. But I think if there's demand for more different hosting options and that kind of thing, certainly we're willing to expand and be more flexible there.
Got it. And going back to Vijaya's question, they said, yes, it is quality assurance. So going back to that question, how did quality assurance adopt this transformation to serverless architecture?
Mm-hmm. So I guess I actually don't have that much experience with quality assurance.
Mm-hmm.
When I was working at Asana, the way that things mostly worked is we like relied really heavily on automated tests so that we could ensure code is working. And Asana would actually release code twice a day, which is just so fast that having like manual QA process is not really possible. But I guess in general, I don't think switching to serverless drastically changes how your team has to do QA. If you're using automated tests, you can certainly write automated tests against serverless infrastructure, just like you could with your traditional infrastructure. And if you want to do a manual QA process, I think that's also just as easy to do as ever. And maybe in some ways even easier if you can spin up a backend without having to like provision servers and have some kind of staging environment that your QA people use. Because it's, you don't actually have to manage the servers. Having a second deployment of convex out there to test against is super easy.
Right. Okay. And Jacob S asks, does this model imply your product will be a monolith? Do all teams need to work in the same repo and have the same SDLC? Software development
I don't know these
lifecycle.
acronyms. Okay,
Software
I don't know
development
SDLC.
lifecycle.
Oh, okay, got it. Yeah, so I mean, I think certainly my hot take is that I actually love monoliths. I think that having everything in the same repo makes it easier for developers to cross boundaries and jump into parts of the code that they don't normally work on. And I think, having a single software development lifecycle is a often pretty simple model for most teams, unless you're getting up to some huge scale and really want to separate deployments into more granular units. I guess that being said, if you wanted to split things up more, that's also an option. So you certainly could use serverless and have a separate repo for your backend and a separate repo for your front end. I think getting more granular than that, though, is actually not very common. Like in a traditional architecture, you may have many microservices and want to deploy these all separately. But now that you're not really managing deployment at all, it's being managed by your serverless hosting provider. I think the benefit of splitting up these microservices into tiny little pieces, at least in my mind, no longer makes sense because you're not even managing deployments. So if you're using Netlify or Vercel and deploying every time a new commit is pushed, I don't think that this kind of like sharding up into pieces is really necessary anymore.
Right on. I think that's all of the, it looks like my connection is having issues. Can you still hear me?
Yeah, I can still hear you.
Just got a big red notification. All right. Good to hear I'm still here. It looks like that's all of the serverless questions. There's one question about React Native. So if anyone has any more questions, please post them in the chat. Otherwise, we will end shortly. But one question about React Native, since you brought it up, Mo H asks, how would you recommend going with React Native in brownfield, a hybrid or a rewrite?
Good question. So I'm not a React Native pro. I think my understanding right now is it's sort of an emerging technology. So plenty of people are still building apps in a more traditional way using Swift or Java to build native iOS and Android things. I would consider React Native if you have a team that is already used to writing React components. I think that makes it much easier to start an iOS project. I think I don't know that much, though, about the integration between React Native and traditional apps. And I think if you're in a brownfield environment where you're trying to transition your app to a new technology, I would just make sure that there's like a really good incremental migration plan. In general, I'm always scared about, do it all at once kind of rewrites where you stop the world and rewrite your app in a new framework. At Asana, we were always very careful to make sure our rewrites were incremental so we could ship pieces as we went. And that made it possible to make some really big changes to our infrastructure.
Wonderful. And then looks like last question is from Iswaria. And I will answer that because Iswaria is asking if you moved Asana into serverless using Convex. And I would say, no, he didn't, because he moved to Convex, and Convex is a newer company. But I will follow up with that in that vein and ask why you left Asana for Convex. What excites you about Convex that perhaps you didn't get while working at Asana?
Yeah, so at Asana, I worked a lot on the reactive data loading framework that Asana built in-house called Luna. And I think it was cool to see how this supercharged our product engineers and enabled them to build new features really rapidly. And so I think part of my excitement in coming to Convex is getting to work on the same kind of thing, but building it for the rest of the community. Because I think that there were a lot of cool things going on at Asana that, yeah, I'm excited to bring to the rest of engineers.
Cool. And why were you so excited to join Convex?
I mean, I think they were thinking about a lot of the same kinds of problems in good ways. And also it's, fun to join a small team with a lot of good people.
All right. Well, Alex, thank you so much for your time. Thank you so much for educating the community on this wonderful new technology direction. Where can everyone reach you?
Yeah, feel free to shoot me an email at alex@convex.dev. And thanks for coming, everyone. This was really fun.
All right. Thanks, everyone, for joining. Thanks for the questions. We'll see you in the next sessions.